Hello, you are most welcome. I'm teacher Ivan from Una Educational Services. I welcome you to our second lesson of projectiles. In this lesson, we shall be looking at the derivation of more mathematical formula for the terms used in projectiles. In our recent video, we looked at how we get velocity at any time. We looked at how we get time of flight and time to reach maximum height, plus how we get maximum height attained by the body. So if you missed it, please go to our playlist, go to A-Level Physics 1, watch that recent video such that we move together as we enjoy the physics. So in this lesson, we are continuing with deriving the formulas used in projectile, and we are to start with getting the formula for range. Range is the horizontal distance from the point of projection to where the projectile lands, and that is along the horizontal plane through the point of projection. So this is the illustration. So assuming it was projected from point O, and then it will move and land at a certain point. So the horizontal distance between the point of projection to where it lands is what we are calling range. So that means that when finding range, we are considering the horizontal distance, and therefore from the second equation of motion, which is s equals to ut plus a half at, then we are interested in horizontal distance, that is sx equals to ux t plus a half at squared. But horizontally, acceleration is 0. And then x, or the horizontal component of velocity, is u cos theta, and then the time we consider here is time of flight. Reason being, the body has landed. So when the body lands, the time it takes from the point of projection to the point where it lands is what we call time of flight. And therefore, when we substitute, we shall end up with the r equaling to u cos theta t, because the acceleration is 0, so we substitute for u t, which is u cos theta t. And when we make, but we shall substitute for t since it is time of flight and we have got its formula. So when we substitute, we end up with the range equaling to u 2u squared sine theta cos theta over g. But from our trigonometric identities in mathematics paper 1, when I have 2 sine theta cos theta is the same as sine 2 theta. So I will replace this with the sine 2 theta, which gives me range as the r equaling to u squared sine 2 theta over g as the final expression for range. So what you must note here is that when finding range, we shall use the second equation and consider the horizontal displacement. But horizontally, a is 0 and u is u cos theta, and since it is range, the time considered is time of flight, and then we substitute for time of flight to get the range as u squared sine 2 theta over g. So that's how we get the range. And then the other derivation is for maximum range. So after we have seen how we get range, then how do we get maximum range? The condition for maximum range is that for maximum range, Sine 2 theta must be equal to 1, which makes the angle to be 45 degrees. If you have ever noticed, when throwing a stone or an object and you want it to travel a longer distance, you normally bend a bit. You are bending in order to get the angle 45 degrees. So, from the formula for range, which is u squared sine 2 theta over g, when we substitute for sine 2 theta with a 1, we shall get our maximum range as u squared over g. So that is the formula for maximum range. Then lastly, this is the formula for the trajectory. Trajectory is defined as the path described by a projectile. And the trajectory is expressed in terms of the horizontal distance, x, and vertical distance, y. And therefore, for horizontal motion at any time, x equals to ut. Because from the second equation, which is s equals to ut plus a half at squared, don't forget that for horizontal motion, a is 0. Therefore, that's why we ignore the a half at squared since it is equal to 0 and end up with x as u cos theta t, because horizontally the horizontal component of velocity is u cos theta times t. So we shall make it the subject from that, which is t equaling to x over u cos theta. In this particular moment, x is the horizontal distance traveled at any time. So when we also consider the vertical motion at any time, we shall get the vertical distance y as u sine theta t minus a half gt squared. And therefore, when we substitute for t with x over u cos theta, that gives us a final expression as y equals to x tan theta minus gx sec squared over u cos theta. And this is what we call the equation of the trajectory. Please, those are the expressions or the formula we had to derive. And once we know this, we can never go wrong on any number from projectile. So let us look at some examples. Example 1. But as you work out numbers on projectiles, make sure you are well versed with the formulas of projectile motion. So you must first of all learn how to derive all those formulas, from velocity to time of flight, time to reach maximum height, how we get maximum height, how we get range, how we get maximum range, and the equation of a trajectory. Once you know that, you can do any number from projectile. So our first example says that a particle is projected with a velocity of 30 at an angle of elevation of 30. They want us to get maximum height reached, time of flight, velocity and direction of motion at a height of 4 meters on its way down. So you can do this as long as you master how to derive the equations. I'm leaving this to you. Number 2 says a projectile is fired with a velocity of 320 meters per second at an angle of 30 to the horizontal. Still they want time to reach maximum height, horizontal range, and the maximum range. Please, you can still do that and comment with the answers. Number 3, we are told that a projectile fired at an angle of 60 degrees above the horizontal strikes a building 30 meters away at a point of 15 above the point of projection. So they want us to find the speed of the projection and the velocity when it strikes the building. Maybe to help you on sketching this, we shall have such a sketch. So as it is being projected, it finds a building and strikes it. So it is projected at an angle of 60 and the building is 30 meters away and the building is 15 meters above the point of projection. And then, so we are given the x and the y. This is the horizontal distance x at any time and vertical distance y at any time. So they want us to get the speed of projection u and the velocity at this moment. So you can play around with those formula to get, for instance, we can get the time from x equaling to u cos theta t. So you can get time from there, and now you can use the time got to find what you want. We can use the time to get u and v. So I want you also to try out that and comment with your answers. So please, that marks the end of projectile motion. I'm teacher Ivan from Una Educational Services. I hope to see you in another lesson. Bye bye. Please don't forget to subscribe, hit the bell, find us on YouTube. We are on Facebook. We are on TikTok. Just search for Una Educational Services on any platform. Follow us on TikTok. Follow our Facebook pages. Join our Facebook groups. Subscribe to our channels so that we enjoy learning together. Bye bye.